Hello, my name's Andrew Williams and I'm an area manager here at Skalar Analytical in the Netherlands. In the upcoming series of videos, what I've done is gather up the 5 most frequently asked questions that we receive from customers via our website, and I'm going to be taking you through the answers to those questions. Our first video, we will begin with our BluVision Discrete Analyzer. So, with that in mind, I'm going to move to our application laboratory. Welcome to the testing laboratory here at Skalar. I'm standing next to our BluVision Discrete Analyzer, and I will now begin to answer the questions we have gathered up. So I'll begin with question 1. What is the available test capacity, or the walk-away time, as it's sometimes called? So if I take a look to the analyzer itself, on the left-hand side, we have a capacity of 100 samples. And if we take the cuvette wheel and the autoloader all together, we have an onboard testing capacity of 640 tests. Also to keep in mind, as we are using cuvettes, so each individual reaction takes place in its own dedicated reaction position, 100% of our testing capacity is used for actual testing because we are able to do the necessary sample blanking in the very same cuvette that the analysis itself will take place in. And of course, during analysis, it is fully possible to add additional samples and to add cuvettes. And actually, that is the role of the operator. For larger batches or more extended runs, the job of the operator is simply to feed the instrument with cuvettes and samples. Okay, so moving to question number 2, how many parameters can be analyzed at the same time? So the answer to that question is actually a function of the available filters for a particular measurement. The filters are actually housed on a filter wheel in this black housing at the back of the analyzer, where you have positions for 8 wavelength filters. But if you consider that certain parameters actually share the same wavelength filter, for example, nitrite, nitrate and nitrite, sulfate and chromium-6, all use 540 nanometers. So depending on the exact combination of parameters, up to 14 parameters can be analyzed from a set of filters. So question number 3 is related to carryover and the steps we have integrated to minimize or even eliminate carryover between high and low range samples. So this is basically a 3-part answer. The first being that naturally between every step the analyzer takes, there is a very robust washing step, rinsing step for both the inside and the outside of the needle. And the second step we have taken is that by using these one-time use disposable cuvettes that I've mentioned, you actually eliminate the possibility of, let's say, carryover or residue from previously used or poorly washed or scratched or poorly maintained cuvettes. And thirdly, to eliminate the carryover effect between the samples themselves, in the sample racks, we have integrated an overpressure and exhaust system. So some things like ammonia, which are very volatile and very soluble, you don't want those to pass from sample to sample. Those will come out and they are immediately taken down and away from the other samples. You do not have this carryover from sample to sample in the sample racks themselves. So that brings us to question 4. What is the length of the cuvettes we use? So when we say length, we're talking about the optical path length of the cuvettes. And actually, as you can see here, we use a 15 millimeter cuvette. And by going to 15 millimeters, that gives us a lot of additional sensitivity, which means we can offer much lower detection limits. So for example, for things like ammonia, orthophosphate, we actually have sub-ppb detection limits, which actually gives us very, very low-level ppb quantification limits. And these kind of detection limits actually would have only been previously available on continuous flow technology. And also the fact that they are disposable eliminates any possibility of poor results coming from the contamination of previously used cuvettes or scratched or otherwise damaged cuvettes, and that really does contribute to these low MDLs, as I've just mentioned. Which brings us nicely to question number 5. What are the options for being able to segregate waste? So basically, yeah, of course, safety first. The safety of operators of the instrument is of paramount importance. So being able to separate waste based on whether that's acids and bases or acids coming into contact with any, say, liberatable cyanide compounds. Also, whilst we're not talking about big amounts of liquid waste, it is nevertheless contaminated, and being able to separate toxic and non-toxic or hazardous and non-hazardous waste, we have integrated that because it is of course senseless to pay a premium for the disposal of relatively harmless waste. And just a last mention of the overpressure and exhaust system I mentioned earlier. That functionality is also active in the in this section of the analyzer as well, to prevent the sort of re-entry of any waste fumes from entering the reaction zone of the analyzer. So that concludes today's video of the 5 most frequently asked questions about our BluVision Discrete Analyzer. If you do require any further information, please do not hesitate to visit our website at www.skalar.com. Thank you very much.